Hey everyone, welcome to day 2 of our unit on probability. And today we are going to be describing the likelihood of an event and actually calculating the probabilities of events. So it says the probability of an event is a number that measures the likelihood that an event will occur. Okay, guys, so probability is just a number. Now, probabilities are between 0 and 1. The diagram below is our probability scale that represents the probability as a number and probability describing the likelihood that a probability will occur. So we can represent probabilities using whole numbers, decimals, or percents, and we know that because we just came off our unit on percents, and we learned how to convert a percent to a fraction, to a decimal, and vice versa. Okay, so if a probability is 0, that means that this is impossible. The likelihood of the event occurring is 0, so that means it is impossible. If your probability is 1, that means the likelihood of that occurring is certain. It is definitely going to happen. So 0 is impossible, 1 is certain. It is definitely going to happen. Now, there are all different probabilities in between 0 and 1. You can have a probability of 1/4, which is equivalent to 0.25 or 25%. If you have a probability that's equivalent or close to 1/4, it's going to be unlikely. Chances are it's not going to happen. You can then have a probability of 1/2 or 50%. That comes right in between 0 and 1 or impossible and certain. So that is equally likely to happen. And if you have a probability that's 3/4 or equivalent to 75%, well, that's kind of close to certain or a probability of 100%. So that is likely going to happen. Okay, guys, so these are all the vocabulary words that we're going to use to represent the likelihood of an event occurring. So we are going to look at different probabilities and determine the likelihood of the event by using this probability scale. So let's look at example 1. Example 1 says there's an 80% chance of thunderstorms tomorrow. Describe the likelihood of this event. Well, 80%, if we look at our probability scale, is going to come right after this 75%. And 75% we know is likely to occur. Well, since that 80% is close to that 75%, we are going to say that because 80% is close to 75%, it is tomorrow. Okay, let's look at some more examples. Again, we're going to refer back to that scale to look at our probabilities as numbers and those vocabulary words to determine the likelihood. So number 1 says, the probability that you will land a jump on a snowboard is 1/2. Okay, well, let's go up to our scale. 1/2 is right here. That is equivalent to 50%. If something has a 50% or a 1/2 probability, we say that that is equally likely to happen. So the likelihood of this to occur is equally likely. Number 2, the probability that you land on heads when you flip a coin. Well, think about that, guys. If I flip a coin has 2 sides, heads or tails. If I land on heads, I have that 50% chance of landing on heads. Again, that's right in the middle here. So we are going to say that this also is equally likely. Number 3, the probability that it will be September tomorrow. Well, guys, just think about that. It's April. I'm not going to wake up tomorrow and it's magically going to be September and we're starting a new school year. That is impossible. That is not going to happen. So that likelihood is impossible. Number 4, there is a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. Well, let's think about that, guys. Am I going to wake up tomorrow and the temperature outside is going to be less than 120%? I'm sorry, less than 120 degrees? Yeah, absolutely. If it was that hot, geez, that would not end well. So, yes, there is a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. So this has a certain likelihood. It is definitely going to happen. Okay, now we're actually going to be finding the probability of an event. And we represent probabilities as a fraction. Now, I did say that we can represent a probability as a whole number, a percent as a fraction, which is absolutely true. But in order to first find the probability of an event, we set it up as a fraction. So it says, when all possible outcomes are equally likely, the probability of an event is a ratio of the number of favorable outcomes to the number of possible outcomes. So this is the notation for the probability. The reason why it says P and in parentheses the event is because that P stands for probability, and then whatever we're finding the probability of, we would write in that parentheses. That's what our event is. So for example, the probability of flipping a coin and landing on heads, we would write capital P, and then in parentheses we would write the word heads because we're finding the probability of flipping a coin and landing on heads. Then we would create our fraction. Now, all we have to know for the fraction is the denominator of the fraction is going to be the number of possible outcomes. So again, if I flip a coin, how many possible outcomes do I have? Well, I can land on heads or I can land on tails. So the number of possible outcomes is 2. So my denominator would be 2. Okay, and then in my numerator, I would write the number of favorable outcomes, meaning how many times can I land on heads? Well, I can only land on heads one time because there's only one head on a coin. So my numerator would be 1. Okay, so let's do a couple of examples. I'm going to go through example 2 with you. It says finding a probability. So you roll a number cube, you roll a dice. What is the probability of rolling an odd number? Okay, well, a die has 6 sides. So the total number of possible outcomes is 6. So 6 goes in my denominator. Now I want to know the probability of finding an odd number or rolling an odd number, excuse me. So I wrote the word odd in my set of parentheses. Now I would have to look at all the numbers from 1 through 6 and determine how many of those are odd numbers. Well, 3, 1, and 5 are all odd numbers. So there are a total of 3 odd numbers. So the probability of rolling an odd number would be 3. So I would write a 3 in my numerator. So the probability of rolling an odd would be 3/6. Now, all the time, like when we have fractions, we do simplify our fractions. So 3/6 would simplify to 1/2. But I'm not really too concerned with you guys simplifying your probabilities just yet. So today, we're not going to simplify. We're just simply going to create this fraction. All right? So let's do some examples together. All right, so for these questions, it says you randomly choose one shirt from the shelves. Here are all our shirts, they're folded. Find the probability of the event and type your answers below. All right, so number 5 says, what is the probability of choosing a green shirt? All right, so what I like to do first, boys and girls, is figure out how many possible outcomes we have. How many shirts do I have in the shelf? Well, we have to count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a total of 10 shirts. So no matter what, the 10 is going to be in my denominator of my fraction. So just to use the correct notation, I'm going to write the probability of choosing a green shirt. Now, type in these fractions, boys and girls. There is a way to do it on Google Docs. There's a lot of steps though to write a fraction. So we're just going to write it as, like, for example, 1/2. My fraction is 1/2. I would just write 1/2. Or if your fraction, I don't know, is 3/4, you just write 3/4. Some of them will autocorrect it into these fractions, but if not, just type in your numerator first, slash as the fraction sign, and whatever your denominator is. Okay? All right, so just wanted to do that as an example. All right, so probability of green. Well, I know my denominator is going to be 10 because that's how many possible outcomes I have. Well, now I got to figure out what is the probability of choosing a green shirt. And guys, all you have to do for that is how many green shirts are there? What is the probability that you're going to pick out a green shirt? Well, there are 2 green shirts, 1, 2. So my numerator is going to be 2 because that's the number of favorable outcomes. Okay, so the probability of choosing a green shirt is simply 2/10 or 2/10. All right, number 2, we want to find the probability of choosing a red shirt. Okay, so probability of choosing a red. Well, I'm looking at my same shelf here. So my denominator is staying the same because I have a total of 10 shirts. So my denominator is still going to be 10. I just have to determine what my numerator is going to be. What is my number of favorable outcomes? Just meaning, how many red shirts are there? Well, there's only one red shirt. So my numerator is 1 and my denominator is 10. So my probability of choosing a red shirt is 1/10. Okay, number 7. What is the probability of choosing a brown shirt? Okay, well, probability of choosing a brown shirt, set up my notation correctly. I simply have to count, well, how many brown shirts are in this shelf? There are 2 brown shirts. So my numerator is 2. My denominator is my total possible outcomes, which are 10. So my probability for choosing a brown shirt is 2/10. Okay, number 8. What is the probability of choosing a blue shirt? Okay, so probability of choosing a blue. Well, how many favorable outcomes are there? How many blue shirts are in the shelf? 1, 2, 3, 4. So my numerator is 4, my denominator is 10. Because again, I still have 10 shirts. Okay, number 9. What is the probability of choosing a white shirt? Okay, well, probability of a white shirt. Let's scroll back up. How many white shirts do we have? We only have 1. So my numerator is 1 and my denominator is 10. So the probability of choosing a white shirt is 1/10. Okay, number 10. What is the probability of choosing an orange shirt? Okay, so probability, type in, of choosing an orange shirt. Let's go up to our shelves. Well, I don't know about you, but I don't see any orange shirts. So how many times can I pick out an orange shirt? Well, since there are none, it's 0. So 0/10. Number 11, little tricky. It says, what is the probability of not choosing a white shirt? Well, since I'm saying, what is the probability of not choosing a white shirt, guys, I'm asking you to determine, I just can't choose a white shirt. I can choose any color but that. I can choose red, green, blue, or brown. So how many options are there? We simply need to count up all the shirts except the white one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 favorable outcomes for not choosing a white shirt. So 9, and my denominator remains 10. Okay? All right, let's try another example. All right, a word problem here instead of a picture. It says, you randomly choose 1 hat from 3 green hats, 4 black hats, 2 white hats, and 1 blue hat. All right, now we got to find a bunch of probabilities. So it says, find the probability of choosing a red hat. Well, ladies and gents, before we do that, let's determine our total. How many possible outcomes are there? And in order to figure that out, we simply have to take all of our number of hats and add them together. So I'm going to do 3 plus 4 plus 2 plus 2 plus 1. And when I add up all those numbers, we should get 12. So there are 12 possible outcomes. All right, so for number 12, we want to find the probability of choosing a red hat. Okay, so the probability of choosing a red hat. Well, how many red hats are in this bunch? There are 2 red hats. So my numerator is going to be 2, and my denominator is my total possible outcomes, which is 12. Okay, number 13, find the probability of choosing a black hat. Okay, so the probability of choosing a black hat. Well, how many black hats are in this bunch? There are 4. So my numerator is going to be 4, and my denominator, again, is my total, which is 12 hats. 14, find the probability of choosing a blue hat. Okay, well, how many blue hats are there? There's only 1. So I only have 1 chance to pull out a blue hat out of 12 possible outcomes. Number 15, find the probability of not choosing a white hat. Okay, so the probability of not a white hat. Well, I can choose any other color except for white. So I can choose 3 out of 3 greens, 4 blacks, 2 reds, and 1 blue. So I simply need to add up 3 plus 4 plus 2 plus 1. That gives me 10. So there are 10 hats that are not white. So I have 10 possible chances to pull out a non-white hat out of 12. Okay, number 16. Find the probability of not choosing a black hat. Well, I can choose any other color except for black. So I can choose from 3 green, 2 white, 2 red, and 1 blue. If I added up all those numbers, there are a total of 8 hats that are not black. So my numerator is 8 and my denominator remains 12 because there are a total of 12 hats. Okay, number 17, find the probability of not choosing a green. So again, I can choose any other color except for green. So there are 3 greens. Can't choose those. So I can choose from 4 black hats, 2 white hats, 2 red hats, and 1 blue hat, which gives me a total of 9 possible outcomes out of 12. 18, find the probability of choosing a red or a blue hat. Okay, so this is different, red or blue. Okay, well, I can only choose the red or the blue. Well, let's see. I have 2 reds and I have 1 blue. So how many hats can I choose from in total? Well, I would have to add here. I can choose from 2 reds and 1 blue. 2 plus 1 is 3. So I have an option of choosing 3 different hats, still out of my total possible outcomes, which is 12. Okay, guys, so when you see that word or, you're adding together those 2 outcomes. Okay, number 19 says find the probability of choosing a black or a blue hat. Okay, so again, I see that word or, so I know I'm going to be adding however many black hats I have and what was it, blue? Yeah, blue. So I have 4 black and 1 blue. So 4 plus 1 is 5. So I can choose from 5 hats. My denominator remains the same at 12. Okay, and last but not least, number 20 says find the probability of choosing a red or a white hat. Okay, so again, I'm going to go up here. I have 2 reds and 2 white hats. So I simply add those 2 together. 2 plus 2 is 4. So I can choose 4 hats out of a total of 12 hats. Hey, boys and girls, you are now going to try the probability worksheet that is on our Google Classroom. You are going to type in your answers just like I did in this video. Okay, and again, you can set up your fractions just how I did with the numerator comes first, hit that slash button, and then type in your denominator. Okay, guys, as always, if you have any questions, please reach out to me.